welcome to what's the title of this? Powering your decoupled static site with serverless GraphQL, or as many buzzwords as I can cram into a title. But thanks for coming. I hope you all are enjoying Decoupled Days. Is this anyone's first time to Decoupled Days? Wow, great. So this is our third one. I'm one of the organizers, and it's probably my favorite conference I go to every year, just because there's so many smart people, curious people, everyone's learning from everyone. So hopefully I will have something today that you can take away and go maybe learn a little bit more about it. So my goal with this talk really is just to kind of open up our minds about what a static site can actually do, and if we can really even call a lot of these static sites really static anymore. So a little bit about me. My name is Bob Kepford. As I said, I'm one of the organizers of Decoupled Days, and I work at MediaCurrent, and been doing Drupal for I think around 10 years now. But I've been branching out recently into more of the JavaScript world, and and I do a Drupal newsletter called the Weekly Drop. So if you do Drupal, that might be something you're interested in. And as I said, I work for an agency called MediaCurrent, which is a distributed company, and I've been working there for 6 years, and it's a really great place to work. MediaCurrent is a full-service digital agency, and we try to implement world-class open source solutions. So we focus on open source, and we do development, strategy, design, and we use those to try to achieve our clients' goals. So it's a great place to work if you're interested in, if you're looking for a job, come talk to me afterwards. I've been there 6 years, and I get to work with some of the smartest people I've ever met and do very interesting work. So it's, that says something in the tech industry, being somewhere over 5 years. So let's get into it. Static sites, or as some people are calling them today, the jam stack. And we do some static site builds, and probably everybody in here has built a HTML, CSS, JavaScript website before at some point. But as I started thinking about it, very, very rarely do we ever get a client need a site very rarely do we have a client need a site that is completely static, but they never need to change anything. And there are good tools for building sites like with Gatsby or with Jekyll, where you can actually edit content, and then you can use the static site generator to generate your content. But more often than not, there's some sort of component that this website needs that has dynamic data, or data that needs to change. And so there's this term that's been thrown around a lot. I've seen it in multiple talks this week, so you probably have heard this defined. If you hadn't before yesterday, you probably heard it yesterday. But there's this term called the jam stack, and it's really just a way to describe what a lot of people were already doing and just give it, a buzzword, so we don't have to explain it over and over again. But I didn't make it up, and buzzwords are what they are. We could fight about them, but what's the point? But what it is, it stands for, I skipped over, JavaScript, APIs, and markup. So using those three things to deliver a site, whereas traditionally you might have a WordPress site or something written in .NET maybe, or in Java. Like, there's all these different ways you could build it, but there's a server running somewhere. It's way more than markup. There's some sort of a server actually generating the content, generating the HTML on the fly. So let's break this apart a little bit. JavaScript, I'm not like a big JavaScript fanboy or anything, but in the last few years I've been diving into it more, and it's kind of growing on me. And we're going to not really get into a lot of technical details, but you could replace a lot of these technologies with other technologies, and it would still be cool. I mean, it would still work, and if those tools work for you, it's not really about the tools. So it's about meeting the client's needs. So we've focused on React in the last few years, just because it's a very complete set of tools. It's modular, and you can use it with Drupal. You can use it with a lot of tools, and you don't have to kind of buy into a huge ecosystem where it's all or nothing. And then recently we've been using Gatsby a lot because it's very fast. It's designed to be very performant. You actually have to work against it to make it slow. So if you build a site with Gatsby, out of the box, it's going to be a pretty fast site because that's the way it's designed to work. and you have to kind of work at it to actually slow it down. And so another cool thing about Gatsby is that it kind of comes out of the Drupal world, so it works really well with Drupal. There's plugins for Drupal, there's plugins for WordPress, and a lot of other cloud CMS providers. There's a lot of a huge ecosystem there. Now the second letter in Jamstack is APIs, and this page could be filled with logos and all kinds of APIs that you could use for different things, but I'm going to focus today on GraphQL. And these other two here are companies, Auth0 and AWS. You could replace those with whatever thing you're comfortable with or you know more about. But the point is that we want to build a site that is not static. We want it to be static HTML, but we want there to be dynamic components to it. So we're going to need to pull that data from somewhere, and we're going to need to authenticate from somewhere. So we need these products. And then the last letter in the Jamstack is markup, and this is just HTML, just that simple. CSS, static CSS files, static JavaScript files, and pretty much any website's going to have those. And the nice thing about a static website is that it's way easier to host, way easier to keep secure, and way cheaper to host. So if you want to host a Drupal site, you're going to, like an enterprise level, solid system behind it. There's great companies that are here this week that can help you with that, but they're not cheap. They're not inexpensive at scale. So if you just start serving up HTML, that's pretty inexpensive to host. So it just opens up a lot more options for you. And I have Netlify on here, not because they're sponsored, but because I've been using them a lot, and because they're kind of one of these companies that have come up while this Jamstack thing is becoming popular, and they're really making the most of it. They're making a lot of this stuff easier to do. So I've been using them on some projects recently. So here's some use cases for Jamstack sites. Let's say you have mostly static content. So let's say you have a client, and most of their content stays the same. Maybe they don't publish every 5 minutes. They're not a newspaper or a blog, like a really high traffic tech blog that's updating content all the time. So, we have quite a few clients that they post a few articles a day or stuff like that, and that makes them a pretty good candidate for a static site. Maybe you need dynamic functionality, but it's very focused on one area. It's not on every page, this is the big one for me. I always have a desire for less maintenance. I don't want another WordPress or a Drupal site to babysit all the time and patch. So to me, that's like a huge win. I'm going to save a lot of my time by avoiding that. And again, I mentioned this already, but desire for less hosting costs. So you're going to save money, at least on the hosting side. And then a desire for more performance, because one of the problems with any dynamic site like that's written in PHP or any other language, whether it be Drupal or WordPress, is you're going to have to cache stuff. Even if you don't do caching on a static HTML site, it's going to beat WordPress and Drupal most of the time. So if you just take it out of the box, so you kind of have performance right out of the gate. So let's say we want to build a static site we can host on GitHub or Netlify, and we need to integrate with some APIs. So this would be like kind of a very simple example of a typical scenario where you have a user log into their dashboard, and in order to fill their dashboard with content, you have to call 3 different APIs or 3 different endpoints. And now your React application is responsible for combining those data points in, mutating that data to be in the format that it needs to be in, and then presenting it to the user. So right off the bat, your React application is not only responsible for your components and the rendering and all that stuff and updating the UI, but it's also responsible for normalizing your data. But really, if we're more honest about the typical use case, you don't usually have a scenario where you've got a React application and then it goes straight to a REST API endpoint. Usually you're going to have a node server that acts as a proxy in between your APIs, your data points, and your client application. So now we have a server to manage, which we really, personally, I don't like managing servers. I mean, I've done it before, I do it now, but I'm trying to get rid of that as a responsibility of mine. So to me, there's room for improvement here. Not to mention that we still have the same problem where we're making multiple requests every time we need to build a component, and we're having to take that data and manipulate it to present it to the user. So that's adding complexity to all of our components in our application. So again, this is making separate requests in one client. So we got performance implications. We have to handle the caching of this API data. We also have complexity in our components, like I said. And again, we're hosting a server, which we want to avoid. At least I do. That's the serverless part of this talk. So this is a different approach. This is something I've been working on with the client currently. And we still have something in between our client and our REST APIs and our data sources. But what we have there now is a GraphQL server. So what we can do with this is GraphQL can be our data normalizing layer. So the front end code that our devs write can just be one query to the GraphQL endpoint, and GraphQL will take care of figuring out where to get that data. And we're going to get into some of the details about how that works, but this simplifies all of our components in our front-end application. And I can tell you from experience that our front-end devs have a lot easier time working with components, and they're able to be very productive when they don't have to do this. But this is really a pattern that has nothing to do with React or the web or anything. It's a pattern of data normalization. And I've seen it over and over at Drupal sites where you have a theme that does a whole bunch of stuff, and you have business logic in your theme, you have business logic in your modules, and it becomes a nightmare to manage over time and support. So we're trying to solve this problem by abstracting out our data layer into its own service that we can manage, where somebody can actually focus on just the data. So let's talk a little bit about GraphQL. I just want to kind of get a feel for the room. Has anyone worked with GraphQL in here? So how many of you don't know anything about GraphQL? Okay, so a little bit. All right. Has anyone worked with it on the server side in the room? Like, so you're the, okay. All right, so we got a really good mix in here. So I won't cut this stuff out. So at a high level, GraphQL is a query language for APIs. It's more of a standard than it is a software project. So there's implementations of it in almost every language. So what's nice about GraphQL is that you can request what you need and only get what you want. So you can request data from the server and only get back to what you requested. That's one of my favorite things about it. Instead of having to make multiple requests and then get a bunch of stuff I don't need, I can just get back exactly what I need. Another nice thing is you could have multiple data sources, but one API endpoint that your clients actually query. So it simplifies a lot of the client-side stuff. And you can pull in many resources with just one request. And then there's growing support for it in the JavaScript community, in the front-end community. It's just extremely popular. Lots of service providers are actually replacing the REST APIs with GraphQL APIs, and there's a reason for that. So that's GraphQL at a really high level. What about a GraphQL server? And serverless is a part of my talk today, and I've already expressed I don't like servers, but why do we need a GraphQL server? Well, we need a server to be that middleman, to be that normalization layer, and it needs to be able to process that stuff. But we're going to talk about how to avoid having another server to manage that you have to take care of. So there's a lot of different GraphQL server projects out there. I'm just going to talk about Apollo because that's what I know. The reason I like Apollo is that it has great docs. It's a very full-featured ecosystem with lots of projects that you can use on the client side and on the server side. It's well established and it's really quick to get started. So I was able to kind of get one set up very quickly, having never used GraphQL on the server side. So if we want to use Apollo and we want to have a GraphQL server, we have to host it somewhere. There's several options. These are just three, but Apollo has its own service, which I haven't used, but I'm sure it's a good service. But so that would be one option, and then you're not worrying about hosting this yourself. You can just use them. You could also host it on your favorite virtual private server, and that supports Node.js. You could do that, but then you're managing that server. Or you could also use Serverless Lambda. So you could use AWS, and that's what I've been doing with it so far. And it works really well. And I don't have to manage keeping a server patched. It scales. It can scale well, and and as far as cost goes, that scales well as well. So, how many of you have heard the term serverless before? And so I will ask you all to hold your Reddit comments or your Hacker News comments to the end. The irony of talking about a GraphQL server that is hosted on a serverless platform is not lost on me. It's actually I like that because it triggers people and it gets people to really start complaining about the term serverless, which is something I've done in the past, but I've moved beyond that. It is like the cloud. It's somebody else's computer, but there's still a computer involved. So I like to call this the 4 pillars of serverless. There's a lot of people saying this is serverless, that's not serverless, or whatever. I mean, it's just a word, but I like to say it's service-based. It has a cloud runtime, so Python, Node, Go, whatever your language is. The pricing is usage-based, so in other words, you're not paying for it just running 24/7. You're only paying for what you use. And then there's managed infrastructure, so I'm not spinning up a Kubernetes cluster. I'm not managing infrastructure. I just use the service I'm using. So that could be something like DynamoDB. It could be something like Firebase. It could be Auth0. All these things are just things I'm paying for what I'm using. And well, maybe Auth0 is not a good example because I don't think that's the way they work, but bear with me. But I like the acronym SCUM for serverless. So service-based, cloud runtime, managed use pricing, and usage-based pricing, and a managed infrastructure. So that's kind of my go-to as far as thinking about serverless. And I'm not going to I don't have enough time. I mean, this could probably be a workshop, but if you wanted to get into serverless, there was a great talk earlier by this gentleman over here on Lambda. And I learned quite a bit from his talk because he's taken a different approach for his org than I have. But I've been using the serverless framework project pretty much just because somebody showed it to me and I thought this was cool. And then I dove into it head first. And then I started looking at other things. I'm like, I think this is better. And I've just kind of ran with it. But it's a deployment tool. It's a CLI and a framework for building serverless applications that's cross-platform. I don't want to deceive you into thinking you can write your project and then just transfer it right over from AWS to Google Cloud or something like that. But there is some standardization in their cross-project. So I highly recommend you check that out if you're interested in serverless as a technology approach. But let's get into it. So here's an example architecture. Which is actually a project I'm working on right now that at some point I'll hope to do a case study on. So we've got, as you remember the diagram we had before, we had a client and then we had our GraphQL server. So this is our client. We're running this on Gatsby. So we've built a Gatsby site and we've installed the Apollo client application, the Apollo client plugin, and that plugin actually makes all the requests for us to our APIs. So when a user comes to their dashboard and they log in and everything, a request is hitting API gateway. So this is an AWS project, similar to Nginx or Apache. It's basically the web server front end that handles all your routing and that kind of stuff. And so it'll hit that, and then if it goes through the authorization and it's a legit request, the query will be made to a Lambda function. And the Lambda function is actually running Apollo server project. So just like if you were going to install it locally, it's going to run the same way in the Lambda function because that's all a Lambda function is a container running a server that you don't manage. Really, that's I'm dumbing it down a lot there, but I mean that's basically what it is. So our Lambda Apollo server then will make requests to the API endpoints that need to be requested to fulfill the query. So let's say I want to pull in all my users' projects. The request would come through to the Lambda function, and then the Lambda function, based on the schema that's written, it would know where to actually get that data, and then it would make the request required to fulfill it, and then return the data back to the user. So Apollo and GraphQL, this gives us a deployment tool. Sorry, that's the wrong note. All right, well, let's talk a little bit about GraphQL and specifically Apollo. All right, so how does this all work? So that was, that's a diagram. Anybody can make a diagram that can be complete vaporware. But just to understand a little bit about the server side of GraphQL. I'm not going to dive into this real deep, but essentially every GraphQL server has to have some sort of a schema, which is basically a schema definition language, or an SDL is the term they use. But the way I understand it, it's a way to describe your data. So in other words, what data sources do you have? Like what kind of entities do you have? And what's nice about GraphQL is it has a type-based schema. So you have your Scholar value types. So you've got like string and int, and there's a bunch of them I'm not going to get into, but you can set all that up so that you're using a type-based system, and this avoids a lot of problems later on, especially with data. And you set up your objects, you set up your relationships, you create your queries, so you have complete control over what your API does. So it's very powerful in that way. So here's an example, like a real simple one. So we've got a query, so we've got a query type, and all this query is going to do is return a user. And the reason I'm naming this the field me is because it's the current logged in user. And then I'm defining what a user is because I'm using it up above in the query, but I have to define what it is. So I define a type, object type of user with an ID of type ID and a name, which is a string. So this is a real simple example, but every GraphQL schema is going to be something like this, just more complex. One of my favorite things about the GraphQL stuff is the relationships. So I have a project defined here, and then every project can have an owner, and then the owner is defined. And so what this allows me to do is make a query where I can use the relationship. So similar to like doing a join in SQL, but much better. So so if I want to get my projects, and I also want not only include the name and the owner, but I want the owner's name. So I can make a query like that, and then I can get my response back with the data, just the data I need. So that's basically what schema is. It's you're defining all of your data, how it relates to each other, what's an acceptable value, whether it's a string, an int, or an array. So you're defining all that, and that's the core thing about GraphQL. The other thing is, so now that we define a query to get a user. How does it actually happen? So you have to build a resolver, and a resolver function is where you tell GraphQL, okay, run this query to get the data you need. So as you can see in the code example, I've got my query defined here, and I have a query for a user, and then I'm passing in some information. So I've got find. So I'm gonna get. It's kind of hard to actually explain. When you start writing it, it starts to make sense. But I'm going to query users, and I'm going to filter it by ID. So you have to pass that into your resolver. So one of my favorite things about Apollo, specifically as a project, as a GraphQL server project, is that it had the caching options that it has built in. So out of the box, you get HTTP cache headers, and you can also save full responses in a cache, like in an actual persistent cache, if you want to. And then you can cache types all the way down to the field level. So you can set expirations on all the way down to a field, whether it's a use. So let's just say there's an example here. I'm going to get into this later, but you can cache a user, but you can cache the user's name for longer than you cache the user. So stuff like that, you can get really granular with it. All right. So we're back to our diagram. We're making a request to Apollo server, or sorry, to the AWS API gateway. The API gateway passes that request into Lambda server, and then the requests are made to the API endpoints. So once those API endpoints are resolved, those responses are cached in a cache. Now this could be DynamoDB, it could be Redis. Depending on where you're hosting this, it can be very different things. But Apollo actually has a really great plugin for writing your own custom cache backend if you want to use something else. So you're able to cache your responses. So one of the big pushbacks I had originally when proposing GraphQL was from the managers of these imaginary APIs who would say, well, what if somebody writes this crazy query and it just makes our server fall over? Which is a very valid concern. So that's why it's really nice. So you can cache, if they're concerned about data being requested over and over and over again, you can reassure them by caching as much as you can, and you just have to figure out like what kind of contract can you set up with those teams. It's like, how long can we cache this? What's acceptable? So here's the cache hinting. So when you have your caching set up in your project, in your schema, you can actually set your cache control on the type level all the way down to the field level. So you can cache things, or you can cache them short periods of time or long periods of time, and you can even set like a default on the query. You can also set it as like a global default's 5 seconds or something like that. So whatever isn't specifically defined can go back to a fallback over the whole thing. Oh, that's it. Yeah, so you can set up a default. So this is just going to cache everything for 5 seconds by default. So we talked about caching and resolvers, but we still haven't got to the point where we're actually getting the data we need. So we gotta do that. And you could get data from a lot of different places, but a very common one is HTTP endpoints. So there's a REST plugin that you can install, and it really is as simple as this. So I have an example here, and you basically just define your API endpoint or your domain if you have multiple endpoints, and then you write your functions to request the data from those endpoints, and then you return it. And this actual function here is going to be defined in your resolver. So whenever a query requires data, it will look at the resolvers, and then the resolvers will look at these functions and call them, and then they will go out to the data sources and get that data and return it back. So it's a little bit different way of managing data that I was used to, but it's very useful. So like I said before, you can cache this data, you can cache these request responses. There's Redis that you can use. In my case, I'm working with AWS, but you could do this with other platforms as well. You can use Memcache. I've been looking at DynamoDB as well, and like I said, you can build your own cache backend if you wanted to. So one of my big questions when I first started considering using GraphQL on static sites was authentication. And once we started working with Gatsby more, I originally thought of it as just for static sites that don't have authenticated users. And it's a great use case for that. But you don't need to limit your thinking to just, if I'm building a static site, I can't have authenticated users, because you can. So it can be, authentication is provided and supported by Apollo. And so what we're doing on this project I'm working on now is we're using Auth0 as our authentication provider. And you can use Firebase or Cognito or many other products that are out there, or open source things that you host yourself. But essentially what it's going to do is that you get your JSON Web Token back from your authentication provider, and then you can use that same JSON Web Token to authenticate your request to GraphQL. So if you have whatever you have in that JSON Web Token, you can actually use as an authorization of whatever queries need to be written as well. So you can have a control mechanism. Yeah?
Is this just for GET requests? Like you would need this authentication?
No. I mean, you can leave it wide open. All the requests are going to be posts, actually. But that doesn't mean they're changing data. So I didn't really talk about mutating data or changing data because that's beyond the scope of what I've been working with. But you can do that with GraphQL, and a lot of people do. But yeah. Yeah.
If that's the case, why not just use GET?
That's just the way GraphQL works. I'm not aware of GraphQL Apollo, at least.
Okay.
So they all the queries are posts. But that's good. I don't know if anybody in here knows why. Has any?
You can change it.
You can? Okay.
I have a hunch that it's because of the GET request limit. Like there's a hard limit on the size of the GET string.
Yeah.
Okay.
Schmidt said that this morning.
Mm-hmm.
That makes sense. Yeah, because your queries can be rather long, so that would totally make sense. All right. So when we add authentication, it's actually pretty straightforward to add authentication to Gatsby. There's pretty good docs, at least with Auth0. I've seen pretty good docs for Cognito as well. Much easier than I thought it would be. So now that we've added authentication, if a user logs in to Gatsby, they go to their dashboard, now a query is made to GraphQL, and at least in AWS, the way it works is your API gateway endpoint, you can have an authorizer that actually will check to see if the request is authorized. There's all kinds of ways you can validate your requests that come into it, but just the simple way, one of the simple things we're doing is we're just checking that token. So we have another Lambda function that's our authorizer function, and we take in the token from the client, and then we check it with auth0, and either accept or deny. And so if they're denied, then their query won't be sent to the Lambda function. But if they're accepted, then the query is passed on to the Apollo server, and then it's the same process we already discussed before. So another thing I really like about Apollo specifically, and this isn't an Apollo project, but it comes included. So you get GraphQL Playground. Is anybody familiar with the graphical GUI editor, which is really nice? It's very similar to that. It's got some features that are a little different, but I really like it. And you can use it on any project because you can install it as on your own separately. But I thought I would drop that in there. So this is kind of what it looks like. So you've got the kind of stuff you would expect. But it's nice to be able to send this to your front-end devs and let them experiment with what's possible. I try to define, like, okay, here's how I would see it, but they're going to come at it, and then maybe they've got a request from a client to change the way the data is exposed. So the great thing about GraphQL, though, is I can define everything that I want to allow them to be able to see or do. The first time I heard about GraphQL, it freaked me out a little bit because it sounded like the client side would just be able to access anything they want to. And like, yes, anything that you expose to GraphQL, that's true. So that's the way I originally thought of it, and I was wrong. So pulling all this together, if you're going to build a GraphQL, if you're going to build a Jamstack site, it doesn't have to be a static site. It doesn't have to have no user-based integrations. You can build all that stuff. You can authenticate your users with a provider, which I really like because then I'm not managing all that stuff. I'm not writing anything to do that, just integration code. You can use their token to authorize their access to GraphQL. And then you can also, basically write your own custom authorization code in a Lambda function or in a function as a service if you're using another provider, and put that in front of your Apollo server. And what I like most about this is this keeps our Gatsby client, like all the components, very simple, or more simple than they would be otherwise. So the project we've been working on, it's been amazing how fast the front-end devs can go on their work and how parallel it is to what our back-end devs are doing. So that's been like a huge win for us, at least so far on this project. So that is I'm going to show this one more time. But that's all I got. Any questions or comments? Anything?
That was the question.
Yeah.
So you're authenticating users and actually pulling like specific user data from GraphQL as opposed to static, like just content from Drupal, say?
We're not pulling anything from Drupal, and the data sources are other apps, other applications like SaaS apps and Salesforce data, which is like not directly integrating with Salesforce, but there's like a middleware REST API that's sitting in front of Salesforce.
And then you're just scraping that into GraphQL, basically.
You're
consuming it,
right? Yeah, and we're currently doing all this in an old site, but Drupal's doing all of it. So
Okay.
it works, but it can be challenging and it's very complex. At least all the Drupal modules are very complex because they're doing all this.
Yeah, and on the other end too, like the front end devs trying to get that data out of Drupal is like a nightmare, right?
Right, especially since it's Drupal 7. But even in Drupal 8,
even Drupal 8,
it's not the best.
Cool.
So,
Very cool.
yeah.
But would it make sense to have GraphQL pull in data from the Drupal JSON API?
I originally considered doing that, and then our lead front-end dev said that was completely unnecessary because Gatsby, we have some of it that requires authentication, some content that does, and I'm not as familiar with how this works, but we're able to hide that those pages from unauthenticated users. But what happens is when somebody's in Drupal and they're creating a page and they publish it, that triggers a webhook on Netlify, and then that triggers a build, and it builds the site out. So it just runs the Gatsby node CLI and then generates a new version of the site. So that's how content creation goes. But all the stuff I've been doing is like user-based data, or like the client is a manager of a bunch of different employees or whatever, and he wants to see reports or the status of things, and so all that can be supported by the GraphQL API. So, yeah.
If you need to flush the GraphQL's cache, how do you do that?
You can in the Apollo client, you can request basically like a uncached version of it there. So you can set the caching. There's a lot of questions I'm still figuring out with caching, though, as far as like where the edges are of where it becomes a problem. But I'm sure that's going to be a thing that where we learn as we go. If anyone else has an answer to any of these questions too, I'm not an expert on GraphQL at the least, but I am learning a lot about it. So just want to share what I had.
Have you been doing anything in your serverless system with persistent queries?
Not yet, no. I've looked at that. Apollo supports that, but no, I haven't yet. Yeah.
Can you go over the API gateway and what's that? And what that's
Sure.
doing? Yep.
The parallel to API gateway is probably Apache, although that's not a perfect example. But if you ever create a Lambda function and you want to expose it to the internet, you use an API gateway for that. And so that'll give you a route, and you can set up, what you can set up there, you can just leave it wide open if you wanted to. But you can also check your cores, so you can do that. You can set that for different settings. You can set up API keys, and that's one thing we're doing is we're using API keys to avoid the clients, like avoid basically a denial of service attack against our endpoints. So you can set up API keys and they can have usage limits. So before the Lambda, so whenever a request comes in, the API gateway, depending on how you have it set up, it doesn't actually hit the Lambda until it passes all these checks that are in the gateway. So you can also, one thing we are doing is, not with the GraphQL so far, but with some other Lambda functions, is we're doing payload validation. So basically, the JSON objects that's submitted has to have these properties, or else it's rejected. They get, I forget the 401, not 401, but 500. And then let's see what else. You can add authorizers. So I talked about that a little bit. So you can use AWS to do that, but you can also use external services like Auth0. You just have to write a Lambda function to do it. So that's, there's probably 50 other things you can do with it that I don't know about, because that's AWS, that's the way it is. It's kind of intimidating, but over time it starts to make sense. Any other questions?
Another question?
Yeah.
You can do authentication through API Gateway. It'll reject the request at the API Gateway level.
Okay.
Is that how you do it?
Oh, yeah. Yeah, I thought you were telling me this.
Oh, no, I was curious, yeah. Because
No.
we do like a Lambda to Lambda call, right? Like through API Gateway into Lambda, Lambda says okay, and then it just used the SDK to call Lambda again. I didn't know you could do it right through API Gateway.
We may be doing the same thing. It kind of looks to me like when you set up a Lambda function, I do it mostly with the CLI.
Yeah.
If you go into API Gateway, if you see your authorizer there, then you're doing what I'm doing.
Okay, yeah.
But you'll see it in both places.
I've never
Okay.
even seen authorizers in API Gateway, so I got to look into that,
So,
definitely.
so to answer your second question, as part of that was, whenever the request comes into API Gateway, it triggers the Lambda authorizer function. If it's denied, your actual Lambda function you're protecting is never
never
fired.
gets
You never
called.
build for it.
Right.
So same with any of the validation. So API keys, payload validation. There's all kinds of resource policies you can set up. I mean, it's actually blown my mind how much you can actually do with it, and it's not that difficult to
Seems
do.
like a really cool way to offload your authorization from your functions, so then your functions don't have to worry about
Yeah.
authorization.
Yeah.
Definitely a good pattern.
Yeah, and there's way more. So I've learned recently that you can actually do a lot of things in API Gateway that you normally would do in a Lambda function. Like if you're just setting one up, it's like a pass-through, like a proxy. It's just harder to write because you have to learn, I think it's VCL, whatever. It's like a language written for API Gateway. So unlike, most of us probably know either Python or JavaScript, and we can write a Lambda function much easier than we can go out and just learn a real complex markup language or whatever it's called. I think it's VCL or something like that. But there's a lot possible. So, and I'm curious, does anyone in here have anything that they're doing with GraphQL or with Serverless or anything that they'd like to share? Yeah.
Well, twinkle in my eye is we're running a testing using a test cafe. And it's a real lightweight, just doing sanity checks on the front or whatever server we want to be. If it's a personal server that we're working on or prod, just real lightweight sanity checks that are Gherkin based. So my idea was to throw that, since it's a pretty fast test, is to throw that up on Lambda, instead of spinning up an EC2 every time we do a test. And then it would just ping the site and test it and give a report back.
Yeah, that sounds like a good candidate. I think it's more of a challenge when you're trying to move like a real big complex application off of an EC2 instance, but that sounds pretty straightforward.
Yeah, that's the only reason I was thinking of it, because the original limit was 5 minutes, but then I found out for this gentleman it's up to 15.
Yeah, which is fairly recent.
Yeah.
Within the last year, I think.
But I don't want to even approach like over 5 minutes. I want the test to go really
An
fast.
API Gateway, sorry if I missed this, but API Gateway has a hard limit of 30 seconds, always.
Yeah.
And so that was part of our, we ran into a lot of problems with that, with doing like shopping cart software. It just takes 30 seconds to do, and so we hit that a lot.
Yeah. Yeah, there's a lot of little edge case problems that you will find.
Yeah.
For example, when I started working on this project, I wanted to use Redis. I, familiar with Redis enough, and as the cache, and I was already on AWS. We already using Lambda to host this, and then I discovered that the cold start problem is actually a real problem when you start using Redis, because you have to put your Lambda function and your Redis instance in the same virtual private connection, and then so that means it's going to take, if your Lambda container hasn't been spun up, it's going to take 10, 15, depending on how much code you have to spin up, it's going to take a while. Because if a Lambda function goes cold, basically it means the container shuts off. So whenever it first gets called, it has to boot up the VM, and then it has to download all the code in your Lambda. So depending on how much code you have, that's adding time to how soon your Lambda can respond the first time. So all those factor in, and we were getting timeouts. So there's a really cool project for the serverless framework that basically allows you to set up cache warmers. And it's real simple to configure, but now I have to add like 30 lines of configuration to my YAML file, and I've got to add in a bunch of code to just handle the warmers when they're calling. So I added all this complexity, and then one night it just dawned on me, why don't I just try doing this in DynamoDB, since it integrates directly, and then I found out, oh yeah, it shouldn't be that hard to write a cache plugin for Apollo, and then oh yeah, somebody already did that, so I don't even have to write it. So that's the kind of stuff like you think through, you're like, maybe this would work, and then you get into it, and you're like, okay, it's got all these problems I didn't know about. So, but overall, the experience has been very positive. It's just been a few little things like that I've hit.
Do you think you could apply this to if in your Drupal instance you had user data and you wanted people to log in through the Gatsby front end and use some sort of authorization to fetch their own user data that's stored in the Drupal site?
So are you talking about a single sign-on type of thing, or where they would log in?
They would log into the site, which would be a Gatsby front end, and then they would type in username, password, and then to be able to see their own user data?
Yeah, in theory, I would say yes, that would be possible. In practice, I would probably stay away from that. I mean, I've had a client that had Drupal as a single sign-on, like a SAML provider for other systems, and it's just, I mean, it's just complicated. I mean, it's not undoable. It's totally, you can totally do it. It's just, you know, that's not the type of work I want to do because it's a headache. When people can't log into not only the site you host, but also the other sites that connect to it, like you got to have some serious systems in place to handle all that. So that is why I like, whether you're hosting it yourself or whether you're using a service, just getting the authentication, authorization side into a separate service. If you're going to have like multiple systems working together, I think it's best to decouple that out of Drupal or whatever CMS and just have it as its own island, and then everybody can integrate with it. And it's not Drupal, like every time you upgrade Drupal, now nobody can log in, or if Drupal goes down or you have problems with it, it just puts a lot of pressure on the team that's developing the Drupal site, to me, or the person that's developing the Drupal site, which is more often the case. But the other part of your question, could you query data from Drupal? Yeah, you totally could. You could expose that data through REST endpoints. Depending on what version of Drupal you're on, that might be easy or difficult. And then, yeah, pull it in as one of these data sources into your Apollo server. Because that was my original plan, was we're using JSON API on the Drupal 8 side. We're just using it with Gatsby. We're not integrating it at all with Apollo right now. So, but we could. We just don't have a need to. So, cool. Anything else? Yeah.
We're currently talking to a decoupled Drupal instance with GraphQL on the front end and GraphQL on the front end of Drupal. We use Firebase for SSR, so I'm thinking putting an Apollo server instance in the cloud functions on Firebase. Would that allow for caching as well?
Yeah, so I didn't really talk about this, but Apollo out of the box, it has in-memory cache. So if you don't set up like a persistent cache like Dynamo, and I realize I'm saying that about Redis and Dynamo, so there's gray area if you want to call it persistent or not, because you can set them all up to be expire and all that stuff. But yes, it would have a cache. I don't know about on like Firebase functions if it would work. Like if you could, I just don't know the system well enough. But you could investigate it and see. I just don't know. But there might already be an Apollo plugin for doing this. Because I haven't ever looked for one. I looked for the Dynamo one and found it. So, all right. Well, hopefully someone learned something. I know I learned a couple things from you all, so I really appreciate that. But yeah, thanks for your time, and feel free to say hi or whatever if you got other questions. And also, thank you all for coming. I've had a good time at Decoupled Days this year, and I hope you have too. So, thanks.